So this is question 2e, parametric equation. So dy by dx equals dy by dt times b dt by dx. So we're going to do that. And they want the second derivative. So I'll just put that here too. So d squared y dx squared. So what we do is that we differentiate the first one, so our dy by dx, with respect to t, but we also have to times it by dt by dx, because it needs to be with x. You see there's no t's in this one. Okay, so we just need to keep that in mind. So dx by dt equals 5e to the 5t, because that doesn't change. So therefore dt by dx equals 1 over that, because we need dt by dtx there. Okay, dy by dt equals 2t, bring that out the front, differentiate that, bring that out the front, and then just leave the e bit the same. Sorry. Okay, so dy by dx is dy by dt, which is the 2t e to the t squared, over 5e to the 5t from the dt by dx here. Okay. So what we can redo is that we can actually rewrite that, because we've got e being the same base, we can subtract the powers. So we'll leave our 2t over 5, that just can stay as it is. And our e now becomes the top one, t squared, and subtract the bottom exponent, which is 5t. It's a little bit like, x to the power of 4 over x to the power of 1, for example, becomes x to the power of 3, just by subtracting your exponents there. I'll just get rid of that. Okay, so that becomes our dy by dx. Okay, so now we're going to differentiate that here with respect to t. This now becomes a product rule. So we're going to go d squared. So that becomes a product rule. So I'm kind of, we can do it just under here. Sorry, it's going to be a little bit messy. F is going to be 2t over 5. And our our g is going to be e to the t squared minus 5t. So therefore f dash equals 2/5. And our g dash equals, right, we differentiate the power, so it's 2t minus 5. And then leave the e, because e just stays as e. Okay, so now we cross multiply those. So we've got 2t to the power of 5. So this, remember, this is just this bit here. This is just this bit. But all we have to do then is times it by dt by dx in the end. Okay. And we're going to times that by 2t minus 5 e to the t squared minus 5t, plus the other way, so g times f dash, 2/5 e to the t squared minus 5t, and then we're going to multiply that all by dt by dx, which is 1 over 5e to the 5t. That's just from this bit here. Okay, right, it's going to a little bit messy. All right, so 2/5 here, we're going to tidy up the bracket bit first. So we've got 2/5 here, we'll pull that out the front, because it's there, and we've also got e to the t squared minus 5t, because we've got two things here. We've got this bit, and we've got this bit, and we're looking at and seeing what's common there. Okay, so we've pulled that out the front. So what am I left with here for the first bit? I'm left with a t from there, and I'm left with the 2t minus 5, The E bit's gone out the front. Now, I've got a plus in the middle, and this whole thing's been pulled out the front, so all I've got left there is 1. Okay. And then, times by 1 over 5 e to the 5t. Okay, that's it, dt by dx. Okay, so what I'm going to do is just combine that bit with that bit there. Okay, so we've got 2 over 25. This e bit's on the bottom line. Okay, so we can just subtract it. Oh, well, we can do that in a minute. So we've got e to the t squared minus 5t. And then this, we've got the 5's gone with this 5 to make 25. And then we've got e to the 5t. We'll tidy that up in a minute. And then we'll deal with this bracket here. That now becomes 2t squared minus 5t plus 1. All right, we're getting there. Okay, so now we've got 2. Remember, we can just subtract the powers again like we did before. So t squared minus 5t is 2 over 25 e to the t squared minus 10t. And then we've got this bracket here. So think of these as 2 types of brackets. Now, for concavity, what we want to know is where the turning points are, because the concavity changes kind of between them with the second derivative. Now, if you remember concave up, we're happy. So that means we're being positive. So that means when our double differentiation, I'm just going to call it y double dash because then I don't have to write the whole thing out, is greater than 0. So that's concave up. Okay. When y double dash is less than 0, it's concave down. So the turning points is where it changes from concave up to concave down is when it equals 0. So that's what we're going to do first. Now, if I was to take this first bracket and let it equal to 0, I would first of all divide by 2 over 25. And then to get rid of the e, which would still be 0, then to get rid of the e, I'd need to ln of it. And so I can't ln 0, so this bit is irrelevant because I can't actually solve that for it to equal to 0. However, I can solve the other one. And you can just use your either quadratic formula or your calculator. And I get t being 2.28 and 0.219. So they're kind of my points of interest with that. Okay, so when we're looking up, now this here is a positive parabola. Okay, so the t, if we think of it as a parabola, that's where my 2t values are. That's 2.28 and 0.219, where it crosses kind of the x-axis in the old thinking of it. So when it's a positive parabola, we know that it's concave, that it's negative when it's between those 2 points. So when it's less than 0.219, it's concave down. Sorry, it's concave up, because that bit there is positive. Okay, so when it's greater than 0, it's concave up. And also the other place where it's concave up is greater than 2.28. So it's also concave up. Now between those 2 points, it's negative. Okay, so that's frowny face. So between 0.219 and 2.28, sorry, therefore it's concave down. Okay, sorry, I know I used a parabola. That's not the actual graph of the thing, but it does show you where where it's positive and when it's negative, and that's what you're looking for. And that describes the concavity of it.